All right, 144, the physics-friendly flyers consulting firm, or the FFF problem, is rather challenging, and so I'm going to try to step it through for you. Hopefully you can maybe take an attempt at it before you watch this video and see how close you can come to getting the correct answer. So we have a St. Louis airline has hired your firm, the FFF, to determine the price of a round-trip ticket to Chattanooga, Tennessee. So you're going to go from St. Louis to Chattanooga and then back, and I want to know what the price of that ticket should be, the average price of that ticket should be. So the information they have gathered to determine that price is that 35% of the time, so 35% of the time, there is a 37 mile per hour wind coming from the south. So that's a 37 mile per hour north wind. North wind. It's coming from the south. So 35% of the time we need that wind adding to the plane vector. The rest of the time, which would be then 65% of the time, there is a 42 mile per hour wind coming from the west. So I'd be going towards the east. So we're going to need a wind that looks like this, 42 east wind. So that happens 65% of the time. That's on the way there. That's on the way there. Ironically, there is never any wind on the return trip. There's never any wind on the return trip. So that's important to remember. The airplane can travel 223 miles per hour. So the velocity of the airplane is 223 when there's no wind being added to it at all. So that's how fast it's going to be going on the return trip. On the way there, it's not going to be going 223 because we have wind that we have to add to it. So we want to figure out the average round trip time that it takes. So then we can, we're going to charge $130 per hour. $130 per hour of flight to figure out what the ticket price should be. Okay, so really what we're going to do is we're going to do two separate problems. We're going to do a problem to figure out how long it takes to get there whenever there's a north wind and how long it takes to get there when there's an east wind. So we'll get two times, and then we'll do a weighted average of those times, and then we'll add on the time it takes to get back. So the equation that we're going to be using is velocity is displacement over time. And we want to find the time. So the time will be the displacement, how far it goes over how fast it was going when it went that time. And that's how we'll figure out the time. Okay, so before we can even start this problem, we need to set up a couple things on the map. So on your map, on the physical map in your book, what you would need to do is you would draw a line. And I'll draw I'll just do a line. Let's do a line. So I would go from St. Louis down to, where's Chattanooga, right there, down to Chattanooga. You need to draw that line actually physically right onto the map. Because what we want to do is we want to figure out how far is it from St. Louis to Chattanooga. Because remember, time is going to be our D over our V, and so I need to figure out for the distance, how far is it from St. Louis to Chattanooga. That will not change in any of our problems. There's just a certain amount of miles from St. Louis to Chattanooga. We need to figure out what that is. So what I would do to do that is I would put a ruler on that blue line right there from St. Louis to Chattanooga, and I'd figure out like how many millimeters long it is. And so I have done that, and you should try this too and see if you get something a little different, then you should do the math with your numbers. But I got that line to be like 179 millimeters long. And then I put a ruler down here on this right here, this scale. And you'll see that little box right there, it says 50 miles. And so I could put a ruler on that little box and see how many millimeters it was. And I did that, and it was 31 millimeters long. Now that's 50 miles. So 50 miles is represented by 31 millimeters. So I'm going to do a ratio, 50 miles over 31 millimeters should be equal how many miles over 179 millimeters. And so if you cross and multiply and divide and you do your math, you're going to get 289 miles from St. Louis to Chattanooga. And so you're going to store that away because you're going to use that in every problem because it's going to be d divided by the v. To figure out the v, we're going to be doing vector problems, obviously. But the d is going to always stay the same. It's going to be 289 miles from St. Louis to Chattanooga. Okay, one other thing we need, though, is we need some angles, some physical angles, because St. Louis to Chattanooga is, east and south of St. Louis, but by what angle? So we're going to actually put in a horizontal line in here, and if you don't know how to do a horizontal line, you should probably measure the same distance down from the top of the map down to St. Louis, and then measure that same distance over here farther and put a little dot and then connect them up because we want a nice perfectly east line there. And then what I do, and I can't really show you doing this on here, but you're going to actually put a protractor on to figure out this angle, to figure out how far south of east is Chattanooga from St. Louis. So you're going to get a protractor, you're going to put the center of the protractor, the hole, right on there, and then the line will line up along this line right here like this, and then you'll be able to see the angle that's right in here, and we're going to be able to use that to do all of our problems. So I did that. I figured out that angle, and that angle was, let's see, it was 42.5 degrees. So we're going to always have that angle as a starting angle to figure out our vector problems. Okay, and I think we're about ready to start. Okay, the first thing we're going to do is not a vector problem. It's going to be super easy because we're going to figure out how much time does it take to get back from Chattanooga to St. Louis. So the time to figure that out is going to be the distance, which is 289 miles, over the velocity that it's going to be traveling as it goes back from Chattanooga to St. Louis. Now, we know that velocity because there is no wind on the return trip. So we do not have to do a vector problem. The plane will go from Chattanooga up to St. Louis, and it'll fly at 223 miles per hour because that's the velocity of the plane when there is no wind. So I don't really need a vector problem. I can take 289 divided by 223, and I get we're going to call this time for return. The time it takes to get back is going to be 1.30 hours. So we'll save that, and we'll use that later. Okay, so now I need to start doing two vector problems. We can decide whether we're going to do the north wind or the east wind first. I am going to decide to do the east wind first. All right, so what do? So we make a vector. So let's make this be an arrow. And we draw a vector from St. Louis to Chattanooga. So we draw that vector in there. And that means that we know that if I draw this little line out here, that means that in here is, what was it? It was 42.5. So this is 42.5. Let's just remember that. Okay, so if I have an east wind, let's see if I can make this a little not as thick. There we go. Okay, if I have an east wind, that means I'm going to have to actually, which way do I go out here? Which way does the plane kind of go out so that an east wind will bring me to my desired place down here? Well, I'm going to have to actually come down a little bit like this, right? I'm going to have to come down a little bit like this, and then there's going to be an east wind that's going to take me on over like this, right? So I would have to, because I know my resultant vector, I know where it needs to be. It needs to be from St. Louis to Chattanooga. Okay? So, what was the east wind? The east wind was 42. Okay, so I'm going to put a 42 right here. And this vector right here is my plane. So that is 223. And if this angle right here is 42.5, that means this angle here needs to be 42.5. So I could put that in there, 42.5. And what I'm trying to figure out is what's the velocity right here of the plane from St. Louis to Chattanooga. So you could use law of cosines or law of sines. I don't have this angle over here, so that's not going to help me. I have this side and the opposite angle, and I have this side, so I could actually figure out this opposite angle. So that's what I'm going to do first. I'm going to figure out this angle right in here first. So that, we'll call that theta, and the sine of theta over its opposite side, 42, should equal the sine of 42.5 over its opposite side, 223. Okay, and I can solve for that angle right in there, and that angle ended up being like 7.3. You should be checking all this math. All right, now I can figure out this angle down here because 180 minus this should give me that angle, right? So that angle in there ends up being 130.2. And now I can use law of cosine or law of sines. I could use law of cosines if I wanted to, but I can also use a law of sines. I could do sine or v, what I want, over the sine of 130.2. would equal, I could pick any of the other ones. I'll do 223 over the sine of 42.5. And I could cross multiply and divide, and I could get the velocity, and the velocity ends up being 252, which makes sense. It's faster than the plane going without wind. The plane going without wind is 223, but see, this east wind is kind of adding on to that, right? So we should actually be able to go faster on a day where there's an east wind. So I'm going to go 252 miles per hour. So how do I find the time that it takes to get there when there was an east wind? You take the distance, and what was the distance again? 289 over the new velocity, 252. And that gives me a time of, let's see, I think it was 1.15 hours. So that's the fastest we're going to actually be able to go to Chattanooga. Okay, so that is when there's an east wind. All right, we'll remember that. We'll come back and get that here in a little bit. All right, let's now do a new problem. Let's go from, we're still going from St. Louis to Chattanooga. I'm going to not make the arrow quite as long. I'll make my picture smaller. St. Louis to Chattanooga. If you remember, I'm just going to put in a horizontal line here so that we can remember that this angle in here is 42.5 degrees. Okay, and this time I am going to have a north wind, a wind that's going up north. So how do I have my plane set out here? Where's it going to go so that if I add a north wind to this vector, it'll make it up to this point right here? Well, I actually have to come down here. I'd have to actually come way down here like this, right? So I could come down here, and then I could add my north wind vector right up there, and that would bring me up to Chattanooga. Okay, so this over here is still my plane without the wind, so it's still 223. Okay, don't worry that it's longer than from St. Louis to Chattanooga. These are velocity vectors. They're not the distance vectors. So I'm just drawing the picture differently. This is going to be 223, and then this velocity over here, which we're trying to figure out, will be something, obviously less than 223 this time. Okay, so what was the wind? The north wind was 37. Okay, so this is going to be 37. What angles do I know in here? I could actually do a little horizontal line through here, and if this here is 42.5, then this angle right in here would be 42.5, and this is 90. So 90 plus 42.5 would be 132. Let's erase this thing right here. So this would be 132.5 degrees in there. Okay. I have this side and this angle. I have this side, which means I can find this angle up in here. So let's do that first. Let's figure out this angle here. The sine of that angle, theta, over 37 would equal the sine of 132.5 over 223. And if I do the math there, that angle should come out to be like, I think it's like 6.96 degrees. Again, I could take 180 minus this and minus this to give me this angle down here. And that angle down there was like 40.5 degrees. Okay, so now I can do law of sines to figure out this velocity. So that velocity over the sine of 40.5 would equal 223 over the sine of 132.5. Okay, and that should give me a, let's see, yeah, that'd be right. Okay, so that velocity I think comes out to be like something like, let's see, I might have, let me try that again. 40.5 sine times 223 equals divided by 132.5 sine equals, I get a velocity of like 196 or something. Yeah, close to that. I found a math error that I did on my original drawing, but I'm going to say, to keep my math right, I'm going to say 190. I'm going to say it's 198 with my originally bad math. So you should be doing the correct math. So technically that comes out to be, I think, around like 196, but I'm going to use a 198 because that's what I have for the rest of my math. So, and that's just not too far off. Okay, so there's my velocity. So how do I find the time when there's a north wind, time when there's a north wind? By the way, the velocity, 198, that's a lot less than 223, see? So that's because we're fighting a wind. We're going into a headwind. So the north time would be the distance, which is, again, is 289, over the velocity would be 198, and that would be like 1.46 hours. 1.46 hours. A lot longer time. Okay, so how do I find the entire time that it takes? Okay, so what I want to do is total time. Basically, I'm going to do a weighted average. I'm going to do the time it took the north wind. Okay, so let's do this. Let's do north wind was 1.46 hours, so 1.46 times the percentage when the north wind. What is the percentage of the north wind? 35%. Okay, so I'm going to take that times 0.35, right? Okay, and then plus the east wind. What was the east wind? It was 1.15 hours. So 1.15 hours times, it'd be 65%. And then I can just add on how much time it takes to get back. What was the time for return? Time for return was 1.30 hours. 1.30 hours. And that'll give me my total time. And if you do that, you get like 2.56 hours. And then the price, if you remember, was $130 per hour. So I'm going to multiply the total time of a round trip, average round trip time, by 130. Hours cancel out, and I will get my final answer for a round trip ticket, which with my math, and my math is a little bit off, so that way it won't give you the exact answer. You can go back and figure out what the exact answer is. I got around $333, although that answer is kind of pretty. Comes out really, really nice there. So that is the FFF problem. Really, really challenging and difficult. That'll allow you to be able to do some other problems on the Jedi trial and also the inquiry as well. So hopefully you understood that. That's the FFF physics problem. It's problem 1.44. Rather challenging problem, and it took me 20 minutes to make this movie.